All right, in this video, I'm going to look at the rest of the transformation problems on this note sheet, and I'm going to look at just the odd problems. I'll put the even problems in the answer key, so if you have any questions about them, feel free to ask, but I'm just going to do 1, 3, 5, 7, and I think that might be it. So problem number 1, we have an apparent function here of the cube root function, and we were asked to describe the combination of transformations that create this new function, g of x. Now, there are a lot of things going on with this new function. So, first things first, we have a 1/6 in front of the cube root. That is going to be a vertical compression by 1/6. What else do we have? We have a negative in front of the x inside of the cube root function. So that is going to be a reflection over the y-axis. Okay. Now, this one's going to get a little tricky. There's a -5 here. However, this function, I'm going to take a second here. I need to move these down just a touch. So let me slide those down. Okay. So inside the cube root function, we have the negative, and then we would have x plus 5. All right. So what's happening here, and this is where you got to be careful, and I don't think I'm going to be mean enough, and yes, I said mean enough, to put this on like a test, because these two pieces affect each other, and so that's where we're not going to ask you guys to do that, but this negative, I factored it out, so that's the reflection over the y-axis. Now inside here, next to the x, it says plus 5, so that's going to be a horizontal translation. Now, I know it says plus 5 here, but because it says plus 5, it actually means it's moving to the left 5 units. And then the last piece, and this is a straightforward one, is the plus 7 at the end. That is a vertical translation. Plus 7 is going to go up 7 units. All right. So those 4 pieces are what changed from f of x to g of x. So if you graphed the original cube root function, and then you compressed it vertically by 1/6, you reflected over the y-axis, had a horizontal translation to the left 5, and a vertical translation up 7, this would be your new function. All right. So that's problem number 1. I'm going to go ahead, like I said, I'm skipping the even problem, so I'm going to go ahead and slide on down to number 3. All right, so what functions do we have here? We have the f of x is equal to square root of x, so the square root function. And we have g of x, which has been slightly altered, okay? So starting on the left here, we've got a 4 in front of the function that's being multiplied times the square root. That is a vertical, it's supposed to be a C. Let's try that again. Vertical stretch. I'm having spelling issues today, sorry. Stretch by 4. Okay. We've got x plus 3 inside the square root. So that is going to be a horizontal translation. And that's to the left 3 units. So inside the transformations with x, where it's inside the radical with x, or inside the root, those are kind of opposite to what you think they would be. So that plus 3 is actually going to shift to the right 3 units. That plus 9 is going to be the straightforward one. That's a vertical translation. Plus 9 is going to go up 9 units. All right, so that's problem number 3 all done. All right, number 5. Let's see what we got going on here for number 5. other than a few parts. All right, the fourth root of x, which is in red, and the h of x function, which is in blue, are graphed and labeled on the coordinate plane below. State the domain for f of x and h of x. All right, so f of x is going to be the straightforward one. We're starting at 0 and we're going to infinity for the domain. So 0 to infinity. Now, because h of x has been shifted 1 unit to the right, we're going to start at 1 and go to infinity. All right. So now the ranges for f of x, we're going to start at 0 and go up to infinity. So 0 to infinity. And h of x, while it shifted to the right, it didn't shift up or down, so it's going to have the exact same range. So 0 to infinity. List the transformations that were performed on the parent function to create h of x. So if I look at h of x, we've got a 1/2 here, and we have a -1 here. So let's write out what those would be. So the 1/2 would be a vertical compression by 1/2. And the second one, the -1, would be a horizontal translation right 1. All right, so those are the two transformations. And you can kind of see the horizontal translations is easy to see here. The compression isn't so easy to see, but it is there. All right, so that's problem number 5. I'm skipping number 6, which is just like the last one. And on to number 7 here. All right, so the graph of the cube root function is shown. Graph and label a new function, which is the translation of f of x 5 units to the right and 3 units up. All right, so I'm going to take the origin. Okay, I'm going to go 5 units to the right, up 3 units, and this is where my new origin would be. So I'm going to graph up and to the right, down. That one started to look horrible there. Down and to the left. Okay. Write the equation for m of x using the given transformations. So we know it's m of x is equal to, now there's no stretches or compressions here, so I don't have to worry about multiplying by anything. So I'm going to do the cube root of x. Now the shifting to the right 5 units is going to be x minus 5. So now my root is done, and then I'm going to do plus 3 outside of the root. And that would be the new function that I drew in pink. Ooh, I forgot to do one quick thing. It did say to graph and label. So this function is m of x. All right, I'm going to go ahead and close the video here. I'm going to make the other answers available on the key. Obviously, ask any questions that you've got. If you have any questions or concerns, email me or see me in Zoom, and I hope this makes some sense in terms of transformations.